These are uncoated drill bits. The coated ones are usually blue. This one got accidentally anodized, it looks like, but that's not a coating. It's just color. The coated ones we use for cutting aluminum, which we don't have any coated ones, nor do we have any aluminum.
So we don't cut any aluminum.
So we don't cut any aluminum. Also, it's really freaking loud. So, and here's an interesting one. Here's a two-fluted ball end mill, or ball mill. You'll notice that it is rounded at the top, hence ball. We found a four-fluted ball mill. Ball mill. Here we go. Here's a quarter-inch. Now their designations they could do by let's see if I can.
Oh, that's better.
Yeah. This is a quarter-inch ball mill. You notice that it is rounded.
Yep.
If you want to do precise things like this Bioshock deal here,
use the rounded ones.
You
instead of
use
square ones?
well, one because it's a flat bottom. The problem with these ball ones is it'll do really smooth cutting, like over like a rounded surface, but it does not do flat surfaces very well.
Yeah,
Like it will not cut a
there.
right angle. The end mills cut perfect right angles, which just makes them really bad for cutting rounded things.
So if you have one of both, you're pretty much in trouble.
You can actually program pauses in the machining.
So you can switch the...
You can actually, you can pause the machining as long as you write down your zero position on a piece of paper. Go back to it. And there are various odd types of bits that we don't use, like these. I'm not exactly sure what these are used for. They're not very useful at all, as far as I know. I haven't encountered a use for them, but they look cool.
I'm trying to focus on it. Oh.
It looks broken.
I don't know what it would be used for.
Yeah. What I think it's used for is going around the outside of a surface and cutting it, but until... I mean, I won't be here anymore. I'll probably come back Christmas break to fix things, but, yeah. I might do a workshop or something over Christmas break, because I manage going to private school. I get, like, a month off for winter break.
Yep.
So, yay me. So we'll get back to various bits later. So moving on over here. Alright, so once you've selected the proper size for what you're trying to do, which is usually based on how precise you're making it, on this one, because it is a
quick thing, you do less precise.
Well, the preciseness settings are later, but really, because this is a flat, you notice that all of these angles are right angles.
Yep.
No, it does wedge too much in there, really, for the CNC machine.
It's gonna get...
well, it won't get stuck. The problem is it won't do the angle properly. Which is
stuck.
another thing you have to look at for that machine versus a 3D printer is some of the limitations. The CNC machine will do a lot wider variety of materials, and they don't actually use CNC or 3D printers industrially for, manufacturing stuff that you'd actually own.
Yeah, but the corners would turn out a little bit less
sharp. Some other machines, like a plasma or like water jet, would cut at that angle. Though our machine, because our machine's like an $8,000 machine or $5,000, it won't do a lot of the things these other machines will do.
I'm thinking more like
the other machines, like the $50,000 machines, will do everything. 4 or 5 axis machines. But so for this, we're just gonna go with 1/8 end mill. All right, because this is all 90-degree cuts. Well, everything's flat.
Yep. There's no rounded surfaces.
Yeah. So you go with an end mill.
How much is it?
Okay, done. You can also edit some other things in it. We're not going to do any of that. There's corner radius. Corner radius, let me see if I can explain corner radius on drill bits. Corner radius does not come up with it for us because we're not doing that advanced things. But corner radius allows you to do sort of like a cross between an end mill and a ball mill. Corner radius, let's see if I can get decent explanation of corner radius. Let's see if I can find a nice flat end mill. Alright, so there's a flat end mill. Corner radius refers to the, let's see if I can get it to focus there on the tip. Let's get some lighting here. Alright, corner radius refers to the,
I think a little bit more distance to focus on. Oh, there.
yeah, refers to, let me grab a pair of tweezers here, and some pointers. Refers to the kind of rounding of the edge here.
Yeah.
So it can be slightly beveled at the edges, and that's what the corner radius. This is 0 corner radius because it is a perfect 90-degree angle. But on some of the ones with corner radius, it'll have slight rounding. Mm-hmm. On the ones with corner radius, it has rounding, and that allows you to do nicer edges, nice smooth kind of sloped curves.
Sort of fillets or something like that?
Like, you might have something that normally be like this if you used an end mill with a nice...
So like when you put crown molding in like a roof,
well,
so
no.
sort of
Let me just finish this real quick. Alright, so if you cut something on one of those, you get a perfect 90-degree cut.
Mm-hmm.
Now, with using one with corner radius, you'd get a slight kind of curve to all of your cuts.
Yeah.
So it'd finish the angles kind of all pretty, like...
Yeah, so it's a bit rounded.
Yeah, it'd have a kind of a slope.
Yeah.
Now, let me fish this thing out of there because I was an idiot and slid it in there. Go. Also another thing, because they're idiots running around here, you keep all the things in this drawer, and no one ever notices this drawer, so you can throw whatever you want. You can throw an iPod in there and no one would notice it.
Yeah, so the design and tech people don't go fishing around there because
basically because they don't realize it's there.
Yeah.
So, I don't
and
know.
They don't really
what it
need
is.
anything
it's
in
sort
there.
of like Sirius Black's house. It's just
there.
no one notices.
Yeah. I think it's there, maybe it's not there.
It's sort of like hiding in plain sight. But anyway.
Because they're more used to being in the center of the room, so the stupid freshmen don't go
Alright,
fishing
so
around
we select end mill. Well, this is a 1/8 end mill. That's fine for this. Done. Then for finishing tool, usually do the same thing because we don't switch bits. You can switch bits mid thing. And some of the nicer machines will actually have all your drill heads on a belt, sort of like a belt-fed machine.
Oh, that's neat.
And it'll automatically go
Swap
to the
them
next
out.
tool. Yeah, we don't have one of those because we're not in Germany, and nor do we have like $50,000 lying around or $100,000.
Sadness.
You could buy it on eBay, but if you got the money. So next one, this just really controls the step over.
So it's always a trade-off between time and
speed
quality.
and like quality. So you can do a really fast machine process that looks
And
like
it'd
crap,
look-
or really, really slow, like hour
Forever.
taking, like entire day taking, multiple day. I've done multiple day cuts on that thing.
Wow.
So, we'll just do high quality. I'll show you what this does with that. And you can adjust this anywhere in between there. So, I always keep the tolerance down.
Let's put it slider towards faster so we're not...
Well, we're not actually going to
Oh, yeah.
So,
I keep forgetting.
feed rates and stuff, like, here's the step over. It's doing, like, about a 1/16 of an inch is the step over currently. Yeah, it's actually exactly 1/16. The rough and cut is doing lesser. I personally do not understand that. But, okay, so there are several options you can do for cutting around various axes, and it kind of gives a good graphic
Indication
on
of
what it
it
does.
is.
X and Y is typically what I do. It takes longer, but the results are nice. Then there are different finishing cuts. There's the waterline cut, and there's the pencil cleanup. Waterline cut on a lot of your cuts is going to be the majority of the time it takes. Waterline cut takes the longest. It is a very long process.
Yeah, so if you want to make like a half sphere,
Now
it's gonna
there's
take forever.
these parameters, which I'll discuss later after we do show this toolpath. So right now it's going to generate the toolpath. Now this is a great menu, other than it doesn't like appear over here and just stay over here so you can manipulate things.
No, they just ran.
So right now you'll see the disadvantage of using the 1/8 with this is that it will not get in these like gaps
or the ends.
But you'll get the shape, which is still a cool shape. Now to see what it actually looked like, you can go over here, right, and you can click hide geometry, and then it will look like this. And this is what it will basically spit out of the machine, provided you don't monkey around with any of the settings in this, which we'll discuss after we finish the Meshcan tutorial. Okay, so another handy thing is it does an estimate machining time. Now note that that is actually a lie. Is if you change anything within the within the step size, if that machine is still on, it is not on. So go ahead and let me turn the emergency stop on that thing. Okay, emergency stop.
Like the cord.
This gigantic red button over here. If you see anything go wrong with this machine, anything
hit
at all,
the button.
You press the button. Now to unpress the button, you twist clockwise, and it should pop out, and it should start making this noise. Now, to check for errors, just initial errors, there's a status. Status 0, you're good. Status 2, which I'll induce right now. Let's go ahead and induce a status 2. Status 2 means it's hit a limit switch. In this case, we're going to have it hit the vertical limit switch, which should be just about there. A second. Okay, so here we go. Here's the status 2. You can hear the little click of the limit switch in the background. Switch it on, and it'll go to 4, and then it'll go to 2. So status 2 means you've hit a limit switch, meaning that the machine has moved too far in a particular direction. Like it's gone too far up, or too far in the X or Y direction, or axis direction. So you can press the button. To fix that, you simply press the button, which depowers the stepper motors. Never try to turn these stepper motors when they're powered up. You know they're powered up when they're really hard to turn, right? Do not try to force it. It will strip a saddle nut, and I don't want to even get into fixing that. Such a nice, beautiful machine. So it should go to 0 now, and we're now at 0. You will see occasionally error 4. Just a simple, or status 4. Simple thing to fix all this. Just press this button, and then go over the machine with error 4, and just it'll have a bunch of prompts. You just click OK through all of it, and close out the program. Then turn it back on. That's all you have to do. That's pretty much how you fix every single error with this, other than 2. If you get any other odd ones, ignore any error codes you get on this. Well, some error codes you get on this, you might get like an error lambda or error sigma, or some really weird symbol that you don't even know existed. That just means you just have to press the power or the emergency stop on this, hit OK. It'll sort itself out, and you can close out of the program over there and press this. Now, the program I'm referring to when I say the program is the Techno G-code interface here. You can just hit OK if there are any problems with that, or you just basically press the power button on that to get out of that if there are any issues. Now, I gave Franco all my contact information, so if there are any problems, he'll just email/call me.
Okay.
So
I think I already have your text.
Yeah,
or
I think so. Yeah,
from when I emailed
you should.
Stuff earlier.
All right, so we'll go ahead and exit out of this, or actually, I'll go ahead and show that one thing. So basically, the time estimate it gives here can be a lie, and that's just based on if your step size here matches your step size or your step over size on the what you did with the tool pathing. So yeah, and we'll just go ahead and exit that. Okay. So if you like this toolpath, you can hit Save Toolpath. Now, it saves. I've set it up so it goes into a post processor called NCD, which is what we need to run that. The the Techno G-code interface runs a specific type of G-code that's specific for the iCell, the Techno iCell, or the iCell machines. And that file format ends with a .ncd file extension. So you need .ncd to run this. You can actually, on this you have two options. Translate execute, which just goes from an NCD and automatically translate it into a .run file and will run it itself. If you do have a .run file, which I've never come across a .run file, you go to Run Translated Programs and it'll look for a .run. Which, that never comes up, I think. Oh, well, you could, if you already have a toolpath that's already been translated, it does show up in this Techno G-code folder, but we're not going to do any of that. Dinosaur, Jesus. We can go around. Translate execute takes the NCD file extension. Yeah. The NCD file extension.
Oh no! The weight's on my shoulders now.
BioShack. My hilarious parody of BioShock. And you can open one of these things. Like, let's go ahead and open BioShock 2. Well, is that my final version of BioShock? Oh, BioShock 4. If I have problems with one version, I'll go to another version. I'll do like an underscore or a dash, and then I'll do like a number to indicate the number, because you'll do a lot of versions with some of these. Like, I got one job to do from David Letterman for transportation modeling, and that took 8 versions to get correct.
Dang.
So that's where I really learned a lot of zeroing stuff. But let's go ahead and open BioShock 4. Now, it'll allow you to preview, and that's what it'll spit out if you have a 1/16 bit in there. It also does this cool kind of drag it around, disappears and reappears. It's kind of cool. But yeah, that's the BioShock thing. I don't really use this because the mesh cam is so nice that it gives you a nice kind of generated image. I should probably just go back to doing this. I'll come back to cut speed and plunge speed. That's also very, very important for different materials, as those bits are high carbon steel and are brittle. So since we don't really like this toolpath because we stuck in the wrong bit size, as we can tell by not pulling up the M at all, we hit done because we don't want this toolpath because it's bad. We go back to this, and I'll show you how to manually set a toolpath. So go over here to pick tool because we picked the wrong tool, and we're gonna go with this is 0.063 is 1/16 of an inch. We'll hit OK. Or done. Yes. Okay, and then for this one, we'll also do in mil 16. Now, for the roughing cut, it gives 2 separate versions. You have the roughing cut over here, and then you have the settings for the finish cut over here. Roughing cut you have to do with wood material, and it's nice to do with foam occasionally. Depends on what you're making. You have to do a roughing cut with wood because wood chips easily. And also, your bits will snap if you go too fast on wood, so it's good to do a roughing cut before you try to do any fine work. So just go ahead and leave that. I just leave all these things the way they are, other than step over. Step over, you change based on what you're trying to do, based on preciseness. If I want to make a really precise cut, I do like, zero there, put like, sometimes I'll do 0.65. It's all based on the size of your mill. I can do around half that size due to being a 16th mill, end mill. They do make mills. The company we buy mills from does make has mill sizes down to a 64th of an inch. But if you breathe on that wrong, it'll snap. So we don't use those. So go ahead and put in 0.65. That's the step over we're doing. Feed rate and plunge rate in this software and in Meshcam does not matter. when we put it into for Techno ISO, because they allow you to control that the step over speed or the feed rate and plunge speed when you go ahead and select the program. So.